Let's take a look at readability. In readability, your task is going to be to write a program in C that can take some text and assess the approximate reading level of that text. So for example, you might run your program as /readability. Your program should then prompt the user to type in some text, and after the user types in a few sentences maybe, your program is going to produce as output the approximate US grade reading level for that particular text. Maybe this text, for instance, is most appropriate for a 3rd grade reading level. But if instead the user were to type in a more sophisticated text, then your program might output something like, this is more appropriate for a 5th grade reading level, for example. But what does it really mean for a text to be appropriate for a 3rd grade reading level or a 5th grade reading level? Well, taking a look at these examples, we might make a couple of observations. We might observe that first, longer words tend to mean that a text is more appropriate for a higher reading level. We might also observe that if there are more words in a sentence, in other words, longer sentences, that too generally tends to correlate with a higher reading level. In fact, there are formulas that we can use in order to calculate, based on any particular text, what grade level might be appropriate for that text. One such formula that we'll use here is the Coleman-Liao index, which is calculated as follows. It's calculated as 0.0588 times L minus 0.296 times S minus 15.8, where here L represents the average number of letters per 100 words in this text, and S represents the average number of sentences per 100 words in this text. So in order to determine the readability of a particular text, what we need to do is calculate the number of letters, words, and sentences in that text, and then use the Coleman-Liao index formula to figure out what grade level might be most appropriate. So let's take a look at each of those three in sequence, beginning with figuring out how many letters are in the text. In this case, we're going to count the number of uppercase and lowercase letters in the text to determine the total number of letters. And recall that if you have some text, as a string for example, we can treat that string as an array of characters. So if we have an array of characters and we want to find out how many letters there are, we might start by creating a variable, I'll call it letters, that's going to keep track of how many letters we found inside of this string. At first, letters is going to be 0, but we can loop through this string, one character at a time, checking each character to see whether or not it's a letter. The first character is a letter, so we can increase the count from 0 to 1. The next character is also a letter, it's a lowercase letter, and so the count increases from 1 to 2, and we can repeat that process for every character. Notice, though, that if we come across a character that is not a letter, like a space or a number or a punctuation mark, we don't want to count that in our total count of letters. So we shouldn't increment letters here, but when we get to the next character that is a letter, then we can increment the count. And we'll do that for the rest of this string until we end up with a final count of the number of letters that are inside of this text. You might find that C has some helpful library functions declared in a file called ctype.h that might help you for taking a character and assessing whether or not it is, in fact, a letter. Once we've figured out how many letters there are inside of the text, the next step is going to be to calculate how many words there are inside of the text. And this gets a little bit trickier, because we first need to decide what does it mean for something to be a word. And for the purposes of this problem, we're going to count the number of words in a sentence by assuming that a word is any sequence of characters that is separated by a space. So every time you see a space appear in the text, that's going to be an indication that a new word is coming. And so if we were to take a string, again, just an array of characters, and try and find out how many words there are, we might start by looking to see how many spaces there are inside of this string. And if we were to loop through this string, checking for the number of spaces, we might find that there are 4 spaces inside of this string, for example. But we shouldn't jump to then saying that there are therefore 4 words inside of this string. After all, spaces appear in between words, and there's a space after each word, but there's no space after the last word in the string. You can assume that the string we provide to you won't start or end with a space. So even though there are 4 spaces inside of this string, there are actually 5 words in the string. And in general, we can take the number of spaces and add 1 to it to figure out how many words there are inside of any given piece of text. After we figured out how many words there are, the final step in terms of what we need to count up is counting up the number of sentences that appear in that text as well. And again, for the purposes of this program, we're going to assume that any period, exclamation point, or question mark is going to indicate the end of a sentence. So figuring out how many sentences there are in a particular text is just a matter of counting up how many times do we see periods, exclamation points, or question marks. So for example, let's take this text. Congratulations, exclamation point, today is your day, period. In this particular string, you'll notice that there are 2 punctuation marks that denote the end of a sentence. We have 1 exclamation point and 1 period. And so as a result, we could conclude that based on this particular string, we're able to find 2 sentences inside of that string. Once we've counted up the number of letters, words, and sentences that appear inside a given text, the next step is going to be to use those values to calculate what the Coleman-Liao index should actually be. In order to do so, you're going to take these 3 values, letters, words, and sentences, and plug them into the Coleman-Liao index formula. Again, that formula is here. That's a result of multiplying the average number of letters per 100 words by a particular value and subtracting the result of taking the average number of sentences per 100 words multiplied by a value as well, and subtracting 15.8 at the end in order to get an estimate for what the approximate reading level of a particular text is. Ultimately, your program should output what that grade reading level is, but be sure to round your score to the nearest whole number. So for example, if your index is 2.8, you're going to round that and say that it's about a 3rd grade reading level. And your program should output grade X, where X corresponds to the reading level of that text. But we do want to set a minimum and a maximum here. If it turns out that your output would have been less than 1, your program should just output before grade 1. And if the output is 16 or higher, then your program should output grade 16 plus. But anywhere in between, grades 2 through 15, your program should output grade 2, grade 3, grade 4, etc., as it corresponds to the reading level of the program. Once you've followed these steps, you should have a completed readability program where you can type in some text, and your program will calculate what US grade reading level would be most appropriate for that particular text. My name is Brian, and this was Readability.